Okay, day 4, we're going to be looking at limits at infinity. So at first, we're going to be looking at some rational functions, some fractions. First of all, one thing you want to know, the limit as x approaches infinity of 1 over x equals 0. And the reason that is, like if you thought of plugging in, we know for limits we plug in. Now, you really can't plug in infinity, but let's say you did. If I plug in infinity, this is like 1 divided by a really big number. If you did that on your calculator, 1 divided by a really big number, so, maybe 1 divided by 1 and then a bunch of zeros, you're going to see the answer goes off to 0. The answer gets very close to 0. It's essentially 0. If you kept going out to infinity, it would, if you kept going on, it would be 0. Same thing if we go to negative infinity. So even if I do 1 divided by a really big negative number, if it goes to 0, either way, 0 doesn't have a positive or a negative sign. So, now, one thing, when we're finding limits at infinity, we're going to divide the numerator and denominator by the highest power of x in the denominator. And I will say without the coefficient. Okay. That's a double F there. So without the coefficient. Now, this might seem annoying to some of you because last year, you kind of did a shortcut. You did leading over leading to find a limit at infinity. You could still check your answer that way, but we're kind of required for our, NU course to show it in this specific way. So limit as x approaches infinity, we are going to divide the numerator and denominator by the highest power of x in the denominator, which would be x squared. If we look at the denominator, highest power of x is x squared. So we take 3x, divide by x squared. We take the 2, divide by x squared. We take the x squared, divide by x squared. And we take the minus 1 and divide by x squared. So that gives me the limit as x approaches infinity, 3 over x plus 2 over x squared, 1 minus 1 over x squared. Now, here's the thing. So a constant, any constant divided by a really big number. So even if it's something other than 1, 3 divided by a really big number, you could again try that on your calculator. What you're going to see is that goes off to 0. 2 divided by a really big number goes off to 0. Down here, 1 divided by a really big number goes off to 0. So what you have is 0 over 1, which is 0. So that is your answer. So again, limit as x approaches infinity. We're going to divide by the highest power of x in the denominator, which is x to the 4th. So 4x or 40 x to the 4th is going to be divided by x to the 4th. So is 4x squared going to be divided by x to the 4th. Negative 1 is going to be divided by x to the 4th. 10x to the 4th is going to be divided by x to the 4th. 8x squared and the plus 1. Okay, so its limit as x approaches infinity, that'll be 40 plus 4 over x squared minus 1 over x to the 4th, and then 10 plus 8 over x squared plus 1 over x to the 4th. Okay, so basically, this goes off to 0, that goes off to 0, that goes off to 0, that goes off to 0. So we have 40 over 10, which is 4. So for the next one, limit as x approaches infinity, 2x squared over x plus 6x over x minus 2 over x over x plus 1 over x. So highest power in the denominator is x. Okay, so this is limit as x approaches infinity. Well, we got 2x plus 6 minus 2 over x, 1 plus 1 over x. Okay, this goes off to 0, this goes off to 0. Now, what we have to think about, what does 2x plus 6 do as x goes off to infinity? You could either think of that graphically, think of a line, 2x plus 6, as x goes to infinity, so do the y's. Or you could think about, kind of plugging in infinity. 2 times infinity plus 6, going to get even bigger. It's going to go to infinity. Next one, you kind of have your choice as to whether you want to multiply those. Keep in mind, then you would have to FOIL on the bottom. And then you could go from there, or you could keep them separate. You could do limit as x approaches infinity. This would be x over x over x plus 1 over x times limit as x approaches infinity. The next one would be x squared over 5 over x squared plus x squared over x squared. Okay, so it'd be limit as x approaches infinity of 1 over 1 plus 1 over x. Limit as x approaches infinity of 1 over 5 over x squared plus 1. And then basically this would go off to 0. This would go off to 0. So it would be 1 times 1, which is 1. So this whole thing would be 1. This whole thing would be 1. With the next one, limit as x approaches infinity of 1 plus the limit as x approaches infinity of cos of 1 over x. So the limit as x approaches infinity of 1. The limit of a constant, we said, is the constant. Limit as x approaches infinity of cos of 1 over x. Well, again, if you kind of thought of plugging in infinity, or just as we've been saying, 1 over x goes off to 0 as, x is approaching infinity. So this is 1 plus cos of 0, which is equal to 1 plus 1 or 2. Remember, cos of 0 is 1. Okay, looking at some trig. Now, we know yesterday we talked about, day 3 notes. We talked about limit as x approached 0 of sine x over x was 1. This is different. This is the limit as x approaches infinity of sine x over x. What you have to do here is you have to kind of think about, what if I plugged in infinity? Okay, sine of infinity. Well, think of what the sine curve does as you go off to infinity, an x value of infinity. Your sine curve just keeps bouncing between -1 and 1, right? Sometimes it's at 0, sometimes it's at 1, -1. Oops. Goes back up, hits 0, keeps going, right? So this goes between -1 and 1 over a really big number. We've said a constant over a really big number is 0. This, if we thought of plugging in, now you really can't plug in infinity, but if we thought of it, we've got a really big number divided by something between -1 and 1. Now, initially, it might seem like, oh, well, then that's infinity. Well, it's not, because this could be 0, right? There's places as sign goes off to infinity where it hits 0, which over 0 means undefined, which for limits means does not exist. So because there's places it hits 0, we have to say does not exist. This would be infinity plus sine infinity over infinity plus cos infinity. So infinity plus something between -1 and 1. Infinity plus something between -1 and 1. So the -1 and 1, 0, whatever, 0.5, whatever number it is kind of insignificant. If you have infinity over infinity, that's going to be 1. Limit as x approaches infinity of inverse cos of x over x, 1 over x, minus 2 over x. This is the limit as x approaches x approaches infinity of inverse cos of 1 over 1 over x. Oops, sorry, this was 2x over x. Yeah, 2x over x, so then that's minus 2. As we go to infinity, that goes off to 0, so this is just inverse cos of -1/2, which is saying where is cos 1/2? So basically when we did inverse trig, inverse cos, so remember, inverse cos, we're going to look between 0 and pi. If it's inverse cos of a positive value, then it'll be, my quadrant 1 angle, or, if it's on the unit circle, it would be, 0 pi over 2 or pi. It's a reference angle of pi over 3, but in quadrant 2, because inverse cos is negative. So my quadrant 2 over 3 angle is 2 pi over 3. All right, limit as x approaches infinity, inverse sine x over x, 1 over x minus 2x over x. So it's limit as x approaches infinity of inverse sine of 1 over 1 over x minus 2. That goes off to 0, so I have inverse sine of -1/2. Now, inverse sine was different. Inverse sine, negative pi over 2 to positive pi over 2 is where we look. So if inverse sine is negative, here the reference angle is a pi over 6, but I'm in quadrant 4. Sine is negative in quadrant 4. It's positive in quadrant 1. So if I'm in quadrant 4, this is where I say negative pi over 6. Limit as x approaches infinity, pi x over x, 1 over x minus 6x over x. Oops, I lost sign. Limit as x approaches infinity of sine of pi over 1 over x minus 6. That goes off to 0. So we're doing sine of negative pi over 6. Sine of a negative pi over 6 is negative 1/2. That's actually just the opposite of the last problem. The last problem is asking inverse sine, which is asking the angle measure. Now we're doing regular sine of that negative 30, negative pi over 6. So that's negative 1/2. Okay, if it's not a rational function, you're basically just going to think of it graphically. So absolute value, you should know without a calculator, it looks like this. As x goes to negative infinity, my y's go to infinity. E to the x, you should know, goes through 0, 1, shoots up like this. To the left, it approaches 0. To the right, it shoots up to infinity. So they're asking as x goes to infinity. So that's infinity. Next one is just asking e to the negative x. So we just graphed that. It was, or I'm sorry, not e to the negative x. We're asking limit as x approaches negative infinity of e to the x. So e to the x looks like this. As x approaches negative infinity, we're going towards 0 because there's a horizontal asymptote. Ln x, as x approaches infinity, natural log. It's understood that there's a vertical asymptote at x equals 0. As x goes to infinity, y's are going to infinity. If it was negative, or we wouldn't really, I guess, ask that. Limit as x approaches infinity of e to the negative x. So e to the negative x, that is e to the x, but reflected across the y-axis. So that would look like this. So as x goes to infinity, we're approaching 0. This is the same problem, except x approaches negative infinity. So if I look at that same graph, as x goes to negative infinity, my y's are shooting up to infinity. So that is limits at infinity. That's all for day 4.